Welcome, everyone. Thank you for joining. This is the final event of the Flex MBA Online Summit. If you've been joining us for yesterday and earlier today, thank you for attending all of the events that were within the summit, the student experience panel and the career panel yesterday, the MBA admissions speed advising earlier this afternoon, and now we are going to have the mock class. So I'd like to introduce myself. I am Breon Ransom, the Senior Assistant Director for MBA admissions, specifically for the Flex MBA Online. This evening's programming is a mock class that will be instructed by one of Georgetown McDonough's faculty members, Professor Babak Zafari, Associate Professor of Practice. Thank you for being here and giving our virtual audience an idea of what it'll be like to be an online MBA student at McDonough. So can you introduce yourself and, go into sharing what we'll be learning this evening?
Well, thank you, Brian, for the introduction, and welcome to Managerial Statistics presentation. I'm Babak Zafari. I'm Associate Professor of the Practice in Operations and Analytics area. I joined Georgetown in the fall. Previously, I was a professor at Babson College in Boston, and before that, I was a professor at George Washington School of Business, and that's where I did my PhD as well. A little bit about myself. I've been mainly teaching MBAs and MSBA courses over the past 8 to 10 years. My area of research and works are machine learning and statistical modeling. In the context of machine learning, I've been doing natural language processing and text analytics. And in the statistical modeling part, I've done a lot of anomaly detection in the context of healthcare. I currently am the academic director of the MSBA program, Master of Science in Business Analytics, and McDonough. And what I will be teaching today is just to give you some ideas about one of the core courses you'll be taking in the fall semester. And that course is Managerial Statistics. The way we have designed this course is that it's taught by two professors. Professor Dasma Upatra, the Dean of the MBA program, as some of you may know her, and myself. As you know, the classes are a mix of asynchronous and live sessions. So what we see here is what you would be seeing most of it through videos as an asynchronous material. And then you will come to class. That's where we're just going to do a brief overview of what you have seen in the videos. And then we would do more hands-on and just discuss that for that 80 minutes that we have together every week. This course is a 12-week course. And you can see the topics that we are covering from introduction to statistics, descriptive statistics, probability, random variables, continuous distribution, and sampling distribution. This is where you will be having your midterm. And then week number 7. So the first 6 weeks are recorded by Professor Dasma Upatra, and I will be doing the second half of the course. Even though we are working on a weekly basis now, we are designing this whole the course together. We have divided the live session and the video part among us. So week number 7, that's what we'll be looking today, is confidence intervals. Then this is followed by hypothesis testing, and the last 4 weeks would be on regression analysis, from simple linear regression to multiple linear regression as one of the most popular, as some of you may already know, methods in statistics. And I teach courses in machine learning and programming and optimization. As a core model in machine learning, we still always talk about regression. So this course sets a foundation for many more courses that you may want to take later, or other areas of interest you have in data analysis. So this sets the stage for that. And I'll be going over, again, a few slides, and those are the slides that I've already recorded, and you'll be seeing that as part of the asynchronous material. If there are any questions during the presentation time, please type your questions in the Q&A. If I see it's relevant to the topics of discussion at that slide, I will just answer it then. Otherwise, I'll try to finish a little earlier, and we can take questions. Questions could be about the course, about the program, and up to a point that I know, and Brian is here, she can also help us answering some of those questions that you may have. So any question before we get started? Okay, great. So the learning objectives of these sessions are to differentiate between point and interval estimates of population parameters, calculate and interpret various types of, let me start sharing my slides as well. Okay. To differentiate between point and interval estimates of population parameters, calculate and interpret various types of confidence interval for the population mean and proportion, identify the assumptions for each of these confidence interval estimations, and determining the sample size. We may not go over all of this, but you will get an idea of this whole session, week number 7 of managerial statistics. So what is inferential statistics about? Up to this point, so the first half of the course, you learn more about visualizing data, descriptive statistics, and all of that. And a big part of field of statistics is dedicated to taking a sample and using that sample to say something about the population. And that's called inferential statistics. In fact, in week number 6, just to give you, again, a big picture of the course, in week number 6, you spend a good amount of time understanding what a sample is. What is a sampling distribution? So you will be familiar with some core concept in sampling. Once the sample is available, is ready, is taken, we can use that information for what we call inferential statistics, which means to tell something about the whole population. What we should remember, though, is that these samples should be randomly taken. That's a big assumptions we are making in any of aspects of inferential statistics, because if it's not random, if that sample is not well representing the underlying population, then whatever estimation we do later, it's not going to be valid. So in terms of terminology, we will be looking at two measure sample statistics and population parameter. But before that, let's see what are the techniques for inferential statistics. There are two main techniques: interval estimation or confidence interval, which will be the focus of week 7 of this course, and hypothesis testing. That would be week number 8. When we take a sample, and if that sample is a numerical data, we are looking at average salary of some employees. So we took a sample of 500 employees. We looked at their salaries. The average salary, that would be the sample statistics. We use X bar for that. Well, we took this sample. Why? Because we wanted to tell something about all the other employees that we couldn't sample. So the whole population. The average salary for that is mu. If you're looking at proportions, what proportions of users are using, let's say, a cell phone or a smartphone versus the other group. So when we're talking about a category of yes, no, ones and zeros, or like comparing two categories, we're dealing with proportion. If you take a sample, if you look at that ratio, you use that p hat as the sample statistic. This is also known as point estimate, and the population parameter is p. These are important symbols to remember, because in a lot of the calculation and formulas we use X bar, mu, p hat, and p. So what is a point estimate for that sample statistic? But point estimate is a single value that represents the best guess for the unknown population parameter based on the sample data. Let's look at two examples. For a numerical data, assume a random sample of 500 first-year MBAs is taken. Based on the sample data, the point estimate for mu, for the population, average age of all first-year MBAs is X bar 28.3. So you were curious about the average age of all MBAs in a population. That population also could have a definition. You mean DC area, you mean East Coast, you mean the all US. But regardless, then you took a 500 sample and you looked at the average age, and that was X bar 28.3 years. And imagine taking the same sample, but this time you're looking at the proportions of first-year MBAs that take jobs in finance. The sample statistic, the point estimate in this case was 38.2%. You took this sample to be able to generalize that to the whole population, to say something about the population. In other words, inferential statistics. So this is point estimate. But if we follow the same, so if you took a sample and using that sample statistic, we create an interval that we can also include our confidence into that interval, then we are moving from point estimate to interval estimation. So as an example, for the same sample, you could have said we are 95% confident that the average age of all first-year MBAs lies between 28.1 and 28.5. So rather than just reporting one single number, a point estimate, we are reporting a more informative measure or range, in this case, confidence interval, between 28.1 and 28.5. In doing that, we also said we are 95% confident. We didn't have that when we talked about a point estimate. Similarly, if you're looking at the proportion, then we would say we are 95% confident. We could say we are 95% confident that the proportions of all first-year MBAs that take jobs in finance is between 33.9 and 42.5%. So what is it that you'll be learning today? How do we go from point estimate to interval estimate? Why? Because this is more informative. You can include the confidence level, and that's a better way of representing data. Point estimate could be very biased, could be very misleading. Let me make sure if there are any questions I could answer so far before we look at the first type of confidence interval calculation. Great. So the first one we will be looking is creating confidence interval for the population mean. That means the situation when we're dealing with a numerical variable, where the standard deviation of the population is unknown. Why did I highlight this? It's very important to know that there are some examples in statistics where the standard deviation of the actual population is known. It's not that practical, it's not that common, but just to distinguish between those, the one we're learning is when the standard deviation is unknown, which is the more of a real case. You don't know what's the standard deviation of the underlying population. So again, just to reiterate, the point estimate is the statistic taken from a sample that is used to estimate a population parameter. An interval estimate is a range of values within which the analyst can declare with some confidence the population parameter lies. So a point estimate accuracy depends on how representative the sample is. And I talked about that. That's the whole sampling design is a field in statistics. How do you design your survey to make sure you sample the right people? Or like you're getting a sample which is well representing the population. And because of the variation in sample statistic, estimating a population parameter with an interval estimate is often preferable to using a point estimate. Okay. So in week number 6 and the one prior, you would learn about some probability distribution. Perhaps the most common famous probability distribution in the field of statistics, it's called normal distributions. You may have used it before, you may have heard about it. A normal distribution is a symmetric bell-shaped distribution. What are probability distributions anyway? Let's take a step back, because now this is a mock class, and like you haven't seen week 5, 6, and 4. Probability distributions are designed to explain random variables for us. For example, if you go and take a sample of heights of thousands of people, and imagine on the x-axis you have all the you would say from the lowest height to the highest height, and you plot like a bar plot. You plot the frequency of heights which are falling within each of those areas. that's going to have a normal distribution shape. Most of people have similar height. They have average height. Some are shorter and some are taller relative to the rest. So that's normal distribution. Again, you'll be spending 1 or 2 weeks understanding and practicing that. A very similar probability distribution in statistics, it's called t-distribution, also known as student t. It has actually a very funny story why it's called student t or t. This goes back to 100, 120 years ago, where a statistician working for Guinness Brewery found out about, like, he designed or developed this statistical distribution, but he couldn't publish the paper under his own name. So he published it as student. So he called himself a student, and student t distribution, that's what he called, became the student distribution, and now it's just known as t distribution. I think it was Gusset. I'm not sure if that's the right answer to that, but you could look it up. It has an interesting story. So t distribution is very similar to normal distribution. It's symmetric, bell-shaped, and the average is in the middle and so on. But it has one caveat or one more setting, which is something called degrees of freedom. The degrees of freedom, well, let's take a step back. T-distribution was designed to simulate normal distributions, or approximate, for that would be a better word, to approximate normal distribution. So that's why at the base of it is very similar to normal, but then it has this, what I'd like to call it, the knob, or this parameter called degrees of freedom. The larger the degrees of freedom, the t-distribution is going to converge to become exactly what normal distribution looks like. So imagine an approximator, which as you increase the degrees of freedom, it gets closer to the actual thing that it was trying to approximate. Now you may be wondering, what is degrees of freedom? Degrees of freedom is whatever your sample is minus 1 in this context. So as the sample size increases, t-distribution converges to be exactly like normal distribution. So indeed, a t-distribution with infinite sample size or a very large sample size is identical to normal distribution. Why talking about this a lot? Because we'll be using t-distributions for building confidence intervals. So this is the confidence interval formula. Let's understand what it means. The confidence interval formula says, whatever point estimate we calculate, x bar, add and subtract, we're going to do it twice, plus and minus a t value, a critical value, we call it, so from here all the way here, times s divided by a square root of n. Let's understand each part of this formula. X bar is the sample statistic, the sample mean, the point estimate. T of alpha half and n minus 1. What is n minus 1? What is n? N is sample size. What is n minus 1? The degrees of freedom. Then what is alpha half? Alpha, 1 minus alpha is the confidence level. So if you want to be 95% confident, 1 minus 90.95 is 5%. So the alpha is 5%. So here would be 5% divided by 2, or 0.05 divided by 2. What is S? S is the standard deviation of the sample. What is that? If you take a sample of people's height, people's salary, there are some variability. Some are very high, some are very low. Standard deviation captures that in one single number that says, this is the standard deviation. This is the dispersion of data around the average, and that's called S. It can be easily calculated in Excel. A lot of time in our example, we may just report that number so you can use it directly in the calculation. And n is just the sample size. So if I expand this equation, we can write it like this. This is the lower end of the confidence interval, sample statistics minus that multiplier times s divided by n, and the right side, the upper bound, is the sample statistics or the sample mean plus that value. So in other words, we have that sample statistic, that point estimate, we subtract and we add a number to it to form that range which is called confidence interval. Some assumptions is that we need to make sure that the sample is randomly taken, the population standard deviation is unknown, and the population is normally distributed, the underlying population. And in this slide, this is just to elaborate a little bit more about alpha. So the area under this curve is 100% or 1. It's capturing everything. That's the probability distribution. If we say we want to be 95% confident, so this region would be 95. So the area under this region would be 95. So what is left over is 5%. And if 5% is left over, 2.5 of it is here, 2.5 of it is there. This is what alpha is used for, and that's what it means. So the critical value would be the number here on this distribution, where alpha half of the distribution is on the right side of it, and alpha half of the distribution is on the left side of that. That's what the T critical value is. Well, how do I calculate T value? Yeah, understand where it falls into the distribution. How do I calculate it? The T value would be calculated using, could be calculated using a table. There is a table you can look up. You just look at the degrees of freedom and the alpha level, alpha half level, and you just look it up in this table. That's one way to do it. Another way is you go to Excel and type this formula, T.inv for inverse of 1 minus alpha half, comma, n minus 1, which is the degrees of freedom. We would do that together in Excel. So let's look at one example. If we want a 90% confidence interval, the total area in the two tails is 10%. 90%, so 1 minus 90% is 10. That's our alpha. And if alpha is 0.1, alpha half is 0.05. So now, if the sample size is 9, what would be the critical value for T? Well, if the sample size is 9, our degrees of freedom is 8. And we are looking at T of alpha half, so T of 0.05. That takes us to this, which is 1.86. That's the T critical value, which we will be using in this equation. So we're just going to plug this a 1.86 for this number, and the rest we already know what they are. Well, is there any more efficient way we can find that value? Yes, you can do this formula in Excel. 1 minus alpha half, so 1 minus 0.05, comma, n minus 1, which is 8. That will be 1.860, as you can see here. Well, let me give you some idea about the design of these courses. So there is a big part of this asynchronous. So you're watching this, you will pause that, you will think about it, you may go back, but you will be having poll question designed within the videos. So at this point, the video would be paused and these poll questions would pop up and it would ask you, what is the critical T value for constructing an 85% confidence interval for a sample size of 25? Well, you can just go back and follow a formula like this that I showed you. Calculate alpha. Alpha in this case would be 0.15, 1 minus this. So alpha half would be that divided by 2. Sample size is 25. So n minus 1 would be 24. You plug that in Excel and you can find that value. So these are the poll questions. There is interactive learning as you go through the asynchronous session. Let's see if there are any questions so far before I talk about a more maybe familiar topics like, or term at least, called margin of error. Okay. So margin of error is an amount of imprecision in the estimate of the population parameter and determines the length of the interval. You have heard margin of error a lot. When, more than ever, when in the news and media, they're talking about surveys. Well, this survey shows this candidate has 60% chance of winning the election, and the margin of error of this survey was 5%, which means that's how you can calculate the confidence interval. Indeed, margin of error is the total amount added and subtracted from that point estimate. So this whole thing here, which we added and subtracted, it has a name, and that's called margin of error. So if this was our sample statistic, we add and subtract margin of error from it to form those bounds. So it's a label, a name for that whole value that we add and subtract from the sample statistic or the sample mean to create the confidence interval. So in this case, we denote that with E. So you can also write this in this form. But just a reminder, I wrote mu in the middle. Why? Because we took this sample, we went through this whole process just to say something about population, right? That was the whole promise of confidence interval. You take a sample, you calculate all those values, you create that confidence interval to say mu, the population mean, is between these two numbers. So there's another way you can think about margin of error, and that's half the length of the interval. So if you take the whole interval and you divide it into two, that's technically margin of error. So it's also called half length for that reason. Let's look at one example. In the aerospace industry, some companies allow their employees to accumulate extra working hours beyond their 40-hour week. These extra hours sometimes are referred as green time or comp time. Suppose a researcher wants to estimate the average amount of comp time accumulated per week for managers in this industry. He randomly samples 18 managers and measures the amount of extra time they work during a specific week. So the researcher is interested about all managers in the industry, right? So, but only had access to 18. For time reason, cost reason, and many other reasons, often we don't have access to the whole population. So it only asked 18 people. The average, the sample mean, the point estimate, the sample statistic for these 18 managers is 13.56 hours. And the sample standard deviation is 7.8 hours. This is X bar, this is S. The researcher would like to estimate a 90% confidence interval. Okay, so let's see, how do we do that? So in class, at this point, well, this is going to be part of the recording, but there will be more examples that we would do in the live class. I will pull up the example, and you would have a few minutes to discuss it, depending on some of the examples are smaller, some are larger. You may do breakouts, you may just do individually. So you would spend some time doing hands-on. And I think that's the value of those live sessions, that you get to do stuff. You get to ask your question. You get to make mistakes. And I will be there so you can ask your question. So think of that as one of those examples. So we stop here, and then you have time doing the math, and then we would review the solution together, and then we go to the next topic. So the sample size is 18, so the degrees of freedom is 17. For a 90% confidence interval, alpha is 1 minus 0.9, which is 1, then alpha 0.1, so alpha half is 0.05, and the t-value is 1.74. How do we calculate that? We knew how to do that in Excel. There were 2 or 3 slides had the formula to calculate this. So our confidence interval would be written in this form. We have the sample statistic, the point estimate, 13.56. That was the average reported by 18 managers, plus that multiplier, this one, times the standard deviation, which was reported, S, divided by square root of n, which is 18. This is the confidence interval. So we can say the researcher is 90% confident that this interval contains the average comp time per weekly by all managers. In other words, the average comp time per week by all managers is between 10.36 and 16.76. There could be another question asked. What is the margin of error for this interval? The margin of error would be half the length. So if you had the confidence interval, you can calculate this length. Also, you say 16.76 minus 10.36, that will be the length. Half of that is the margin of error. That's one way we could do that. Another way is just like calculating this number, and that should be 3.2. So this is the average we got from the sample. We add 3.2 and we subtract 3.2 from it to form this 90% confidence interval for these managers. Let me pause there and ask you a question. And again, this is my presentation. There is no right or wrong or like bonus points or any of those. If I would have, it's a conceptual question and I haven't discussed it yet. So just, I'm curious. What if I would have built a 95% confidence interval? This is 90%. Let's go 99% confidence interval. Would that be a wider confidence interval or a narrower confidence interval? So if this is our confidence interval, would you think we're going to have something like this, or we have something like this? So let's call this option A. Let's call this option B for the 99%. You can put your answers in the chat box in the Q&A. For a 90, if you wanted to be 99% confident, would you go to it? Would it be a wider or a narrower confidence interval? You can put it in the chat first rather than Q&A. That will be easier for us to see. Questions, Q&A, answers like this in the chat. Any thoughts? I'll make sure I don't use this again. I don't use wrong answer against you in the fall semester. So looks like I'll be the one that would take the bonus point. So, well, there was one answer, option B from Brian. If you want to be 99% confident, you need to, well, what happens is not that you need to, the whole range would increase. And there is always one good way of thinking about it. If you really wanted to be 100% confident, what range would you give? The widest range. If I would have told you that I'm 100% confident that the interval or the average comp time for all managers is between 0 and 100, probably that was the correct statement. So if you really want to be confident, what happens is this interval becomes wider and wider because you want more confidence. The price you pay for it is that this range becomes wider, and you can see if it's wider, it's less informative. So where do we stay in that trade-off of confidence and length? That's something that we would discuss. And the most common confidence level is 90%. Okay. Well, you may wonder, how do we do this in Excel? Do I have to type this? There was another answer. Oh, I didn't know the chat is disabled. Sorry about that. So you can put your answers in the Q&A if it was the next one. Thanks for letting me know. So how do we do this in Excel, or are we going to do this manually? Most of programming languages, softwares, they create or generate confidence interval. But there's an easy way we can do this in Excel. So in Excel, we can create an Excel sheet that would have all the parameters that we have. I've created one for myself, and that's the one I've taken snapshots for the slides. So we will put the sample size, the sample mean, sample standard deviation, and I'll show you in a second the whole Excel file, the confidence level, and then 1 minus that, which is 0.1. And there is a formula in Excel for this one. It's called confidence.t, which returns the margin of error. So this returns the margin of error as I have it in cell B7. Once I have the margin of error, to know the lower and upper bound, all I need to do is add and subtract this number from the sample statistics as we calculate. So 13.56 minus 3.2, 13.56 plus 3.2. That's going to give us this confidence interval as we cited before. So let's take a look. So this is, just want to make sure if you can see the Excel. Brian, if you can confirm, please. Thank you. So our sample size, our sample mean, sample standard deviation, and here you can see the formulas. There we go. So sample mean. And going back to my question, this was for 90%. Let's remember what we have here. I'm just going to copy and paste these two values here just to keep it for us. And I'm going to change this to 99%. Look at the range right now. It's from 8.23 to 18.89. That's such a wide range, which may not be that informative. If you go to your manager and say, oh, yes, that range is between 8 and 18. The question is it closer to 8? Is it close? This is such a wide range. How do I make decision? Because remember, a big part of what we learn in these classes is how to convey information, how to use information to make better decision, a data-driven decision making. So this is definitely more difficult. Of course, you're 99% confident, but the price you paid is a very wide range. And this was the 90% as we did before. Let me see if there are any questions here. You can use the Q&A to ask your questions. Okay, so what I'm going to do, so we had two parts, but I'm just going to do the first part. And I think that should give you an idea of where this whole thing is going. The last part is sample size calculation. I'll briefly talk about it, but let's keep this as our last part of discussion as an introduction to confidence interval. Then we would see if there are any questions you may have, so I can answer. So what we did before in the previous example, in the previous part, was creating confidence interval for population mean, average salary, average working time, average height, many more things that are numerical variables. Here, we want to look at proportions or categorical data. The good news is the confidence interval to estimate proportion has a very similar format. Again, it's going to be a point estimate plus and minus a margin of error. In other words, a point estimate plus and minus a multiplier or like a critical value times that standard deviation divided by n in a slightly different form. So generally speaking, has a similar format. But what are the exact values? These are the exact calculation here. And don't let these parameters and numbers, because some of us, and if you haven't done data analysis for a long time, when we see a statistical mathematical notation, it may not look friendly, for a lack of a better word, but let's understand them. That's more important, because a lot of time in practice, you just have these numbers and you're going to use it. You may rarely go back to this formula, but someone that has good understanding of how those numbers are calculated, that's the person that can contribute more, which can make changes to the analysis, to the whole sampling process, everything. So what we have here is point estimate, in this case, sample proportion, plus and minus, rather than a critical value in terms of t-distribution, we have a critical value in terms of a normal distribution. Normal distribution is usually denoted by z, times p hat times q hat divided by n. What is p hat? Proportion, sample proportion. You would say 55% of people said candidate A. So that's going to be 0.55. Then what about q hat? Is 1 minus that. So if this is 0.55, this is going to be 0.45. If this is 0.8, this is going to be 0.2. And n is the sample size. Again, this is like having a point estimate, adding and subtracting a margin of error from it. What is the margin of error? Is this whole number or value that we are adding and subtracting from the point estimate. Two assumptions. We have taken a random sample. That's the first assumption. And the second is we have at least 5 successes and failures. We have at least 5 people voting for candidate A and at least 5 people voting for candidate B. We're saying we're going to vote for that. So that's just to make sure we have enough representative from each of them. So how do we do that? If you have the sample size and you have the p hat, if you just multiply them, each of them should be more than 5, greater than or equal to 5. So here, a poll question would pop up. The video would be paused, and this is what would be asked. A random sample of 30 students is taken. 10 students are married and 20 are unmarried. Does this satisfy the assumption that we needed to use the confidence interval for P? Yes or no? So what you would do here is you need to make sure if you have at least 5 in each of these groups. So you have 5 married and you have 10 married and you have 20 unmarried. So yes, each of them individually is greater than or equal to 5. So yes, that assumption is met. Then we would look at one example here. A random sample of 50 people were asked to compare 2 smart voice assistants, Amazon Echo and Google Home. And you can see how very simple, like confidence interval could be a very, like in statistics, it's a very basic or core model, but how this can be important if you're working in a marketing team and you want to design a survey and then use that information to introduce a product, to design campaigns, and many more things. In fact, if you're familiar with A/B testing, that has some elements of this. So after trying both devices, each person was asked which device they preferred. 29 out of 50 preferred Google Home. And the question is, find the 95% confidence interval for the proportion of all people that prefer Google Home to Amazon Echo. So you want to know, you just took a sample of 50 users, but you want to say something about a bigger population just using this sample. So what do we do? P is the proportion of all people that prefer Google Home to Amazon Echo. The sample proportion in this case, the P hat is 29 divided by 50. That's 58% or 0.58. If this is 0.58, then you can imagine that Q hat is 1 minus this, which is 0.42. Sample size is 50. And we want to make sure we have at least 5 in each group. We do. 25, they said Google Home. 29, they said Google Home. So that means the rest, 21 people, they have said Amazon Echo. So we have at least 5 in each of the groups. So check, check, check. We have all these numbers. The next step is just to plug these numbers in the formulas. So P hat 0.58 plus and minus 1.96. How do we calculate this? This is called critical value, but not in terms of the t distribution. This would be in terms of a normal distribution in this case. So the formula would be norm.s.inv in this case, because if you remember, the previous one was t.inv, t distribution inverse. Here is normal standard inverse. So that gives you 1.96. You have seen in week number 5 and 6 some of these formulas, some of these tables. So these are just reminders at that point. So 0.58 was the sample estimate or point estimate, 1.96, check. P hat 0.58, Q hat 1 minus that, N 50, you plug these, and this is what we get. What does that mean? It means we are 95% confident that the true proportion of all people that prefer Google Home to Amazon Echo is between 44.3% and 71.7%. Is that an informative range? It's such a wide range. It's informative. We have an idea. It's between 44% and 71%, and I'm 95% confident about that. I know if I want to be more confident, this is going to be wider. If I want to be less confident, yes, this is going to be narrower, but then my confidence level is dropping. So what is one way that we could improve this? And that would be, we are skipping that today, but that would be the next part, which is sample size. If you go and ask more people, the larger the sample size, the smaller the margin of error. So this would be narrower, this would be more informative. So that's perhaps the most important way, or one way that you would control the size of the confidence interval. And there will be a question popping up here. What is the margin of error for this previous example? And here's just to test your knowledge that you know the margin of error is the half of the length, or is just the multiplication of these numbers after the point estimate. So you would do that, and then you would move to learn how to do this in Excel. This Excel formulation is slightly different. So we have this one this time, where you have the sample size, the sample proportion, which is 29 as reported in the problem, divided by 50. Q hat would be 1 minus that. You set the confidence level and you calculate the Z value. There is no nice and easy formula like the previous one that gives us the margin of error. So here we need to calculate it ourselves. How do we calculate that? Margin of error would be this Z value, that critical value, times square root of P hat times Q hat divided by N. Once we have that, we would add and subtract that from the sample proportion to get this range of 44.3 and 71.7. In other words, just to reiterate, we are 95% confident that the average proportion of users that prefer Google to Amazon, it's between 44.3% and 71.7%. Again, there will be these are examples that you would do in the live class. There will be some managerial question in some points asked, and we give you time. You would work on that, and then we discuss that, and we move to the next topic here. So the next one is determining sample size. We're not doing that, but that will be another step. That what if I can fix the margin of error? I want a survey which is margin of error is not more than 2%. Tell me how many people should I survey? This is also very common in marketing teams, that they determine the sample size needed for a task, for a project, for a campaign. And then from there, and this is exactly the reverse of confidence interval calculation, as we would do here, to get a formula like this, which then you plug numbers and tells you, if you want your margin of error to be 2%, this is going to be the sample size. And if you want to be 95% confident, this is the required sample size. And eventually a table that summarizes all that information. So I want to make sure I give you enough time also if you have any questions you want to ask. So please let us know. Please use the Q&A.
Thank you, Professor Zafari. That was really awesome coursework on managerial statistics. I think I learned a little something, but I think it's a lot for me to kind of take in, whereas I don't have like a strong quant knowledge background, like from undergrad and things like that. But those individuals who do definitely have that background, I'm sure they definitely took away a lot of things. And you saw my guess, I was like loud and wrong.
No, that was okay. Thanks for mentioning that. And just to clarify, Brian, for everyone on the call, again, this session is not taught live, and this is week number 7. So by week number 7, you have built a lot of understanding of some of the underlying models that you're seeing here. Got it. There is an asynchronous part, which you spend time over the weekend at evenings. Most of like our students in this program would be working professional, that you pause, you go back, there is a textbook, so you can go and read about it. So when you come to class, you already have some foundational knowledge of like what we will be discussing. So you come to the live session to ask your questions, to make those mistakes. I always call it in a safe space, so we can correct each other and learn from each other and do some more hands-on to wrap that up. And then there will be an assignment coming up, which then you would get a chance to do it one more time.
Awesome. Thank you for that insight. And that just goes back to the type of community we have as well, like to assist others, who may not kind of get it right then and there, but kind of like coach them to that point. That's awesome to know.
Definitely. And most probably, and in fact, Professor Dasmalpatra and I, we are meeting tomorrow to discuss now the assignments, because now we are halfway through the recording. We are doing a studio recording and everything. There's a good chance that you will be working in teams of 2 for the assignments, because there is always value in learning from each other. And in one topic, I might be better, in the other topic, another person, but explaining concept to each other reinforces. Like for me, many times in the beginning of teaching, like whenever I started teaching something, then I found holes in my knowledge because I thought it makes sense. But then I started telling someone that this is what it means. When you start teaching it, when you tell someone else, then that's when you need to learn it in more detail, and that's where you would learn it forever. So it's always value in like helping each other in that.
Exactly. Thank you.